Good morning, doctor. My name is Chai Chien Ho, BB2311050, and I am the group leader for Group 1. Today, we will begin the Chapter 4, Allocator Research over time.
Hello, my name is Zoe Ziling and my matrix number is BB231104440. I am going to present for question 3. For this question, what is the present value of the following cash flows at an interest rate of 10% per year? For A, we will need to find the present value of $100 received 5 years from now. Given that the future value is $100 and the interest rate is 10%, and the time period N is 5 years, we use the formula PV equals FV divided by 1 plus I in the power of N to calculate the present value. And we will get the answer is $62.09, which means the present value of $100 received 5 years from now would only be $62.09. For question B, it is given that we need to find the present value of $100 received 60 years from now. We will use the same formula whether FV is $100, I is 0.1, which equals to 10% interest rate, and the N is 60 years. Then we will get the answer is $0.33, which means the present value of $100 received 60 years from now is only $0.33. For question C, we will need to find the present value of $100 received beginning 1 year from now and ending 10 years from now. Given the cash received each year, PMT, is $100 and the interest rate is 10%, the time period is 10 years, we will use the present value of ordinary annuity formula, which is PMT times 1 minus 1 over 1 plus I to the power of n, then divided by I. When we substitute the given numbers into the formula, we will get the amount of $614.46. This means that the present value of $100 we received each year beginning 1 year from now and ending 10 years from now will be $614.46. For question D, we will need to calculate the present value of annuity due to know the present value of $100 received each year for 10 years beginning now. The formula of PV annuity due is PV ordinary annuity times 1 plus I. We will take the value of the PV ordinary annuity from the previous question, which is $614.46 to multiply by 1.1, which is 1 plus the interest rate of 10%. We will then get that the PV annuity due amounting to $675.91. This implies that the present value of $100 received each year for 10 years beginning now would be $675.91. For question E, we will need to find the present value of $100 each year beginning 1 year from now and continuing forever. In this case, when the PMT is $100 and the interest rate is 10%, we will just use the PMT divided by the interest rate to get the present value. That is by using $100 divided by 0.1. We will then find that the present value is only $1,000. This means that the present value of $100 each year beginning 1 year from now and then continuing forever would only be $1,000. That's all from me. Thank you.
For the question 4, we need to find the present value. So we can know the PNT is 1000, I is 10%, and N is 4 years. So for the formula, is PNT type 1 minus 1 plus I square minus N divided by N. So the final answer for present value is 3159.87. So it means we need to put $3,159.87 in the funds now that can take 1,000 per year for 4 years when the interest rate is 10% per year. For the question 6, if the interest rate is 50% per year, what is the amount of the money payment? So we can know the present value or loan is 100,000 and I is 60%, but we need to divide by 12 because it's money interest rate. And N is 300 month. So use the formula PV equal PNT times 1 minus 1 plus I square minus N and divide by I. So we can take the monthly payments is $1,358.89. So for question B, if you can only afford to pay 1,000 per month, how large a loan could you take? If this is same question, just the payment change to $1,000. So use the same formula, we can take the person value is $73,589.83. It means if we only can pay 1,000 per month, mean we can take the 73,589 per $83 for a loan. C, if you can afford to pay $1,500 per month and need to borrow $100,000, how many months will it take to pay off the mortgage? So for this question, we know first the person value equals 100,000 and payment equal 1,500 and interest rate equal 60% but divide by 12. So for the formula, PB equal PNT type 1 minus 1 plus I square minus n and divide by I. So exchange to I type PB divided by PNT equal 1 minus 1 plus I square minus n and change again to 1 plus I square minus n equal 1 minus I type PB divided by PNT. So we can know the n is n equal minus in 1 minus I type PB type PNT divided by PNT divide by in 1 plus I. So put the number into so we can get the n equal 155.89 month is also we can call 156 month. So it just means if you can pay 1,500 per month and need to borrow $100,000, so the 1,056 month was take to pay off of the mortgage. D, if you can pay $1,500 per month, need to borrow $100,000 and want a 25 years mortgage, what is the highest interest that you can pay? So we can find the person value equal 100,000, payment equal 1,500, and n equal 3,000 month. So for the formula, PB equal PNT type 1 minus 1 plus I square minus n divided by I. Change to PB divided by PNT equal 1 minus 1 plus I square minus n divided by I. So PB divided by PNT is 100,000 divided by 1,500 and we can get the 66.67 equal 1 minus 1 plus I square minus n divided by I. For this situation, we use the Tre and Euler method to calculate the I. Assume I equal 1.5%. So use the formula 1 minus 1 plus 0.015 square minus 3,000 divided by 0.015 get the 55.9. Mean the money interest rate not equal with 1.5% because more than the highest interest rate that I can pay. SUB, if the money interest rate equal with 1.45%, so use the formula 1 minus 1 plus 0.0145 square minus 3,000 divided by 0.0145 get the 58.05. It means the monthly interest rate not equal with 1.48% because the highest interest rate that I can pay have not yet been decreased. A to C. If the interest rate equal with 1.4%. So for the formula, 1 minus 1 plus 0.014 square minus 3,000 divided by 0.014 get the 66.67. So mean the money interest rate equal with 1.48%. So we need to find the annual percentage rate equal with money interest rate times 12. So equal with 0.0148 times 12 and equal the 70.56%.
Hi, my name is Fitra Alia binti Aliuddin with matrix number BB231107 and 09. So for question 8, in this question, the lottery claims to play $1 million, but instead of giving the money all at once, it pays $50,000 every year for 20 years. So the important point is we are not receiving a lump sum, we are receiving annual payments, which means the real value must be discounted to the present. To find the true worth today, we use the present value of an annuity formula where PV equals to PMT times 1 minus in bracket 1 plus I to the power of negative n over I. PMT is the yearly payment, which is $50,000. I is the interest rate, which is 8% or 0.08, and n is the number of years, which is 20 years. So when we substitute the values, PV equals to 50,000 times 1 minus 1.08 to the power of negative 20 over 0.08. After calculating, we get 490,907 and 37 cents dollar. This means the real value of the lottery prize today is only about 490,907 and 37 cents dollar, not $1 million. So, even though the lottery advertises $1 million prize, its present value is actually less than $500,000 because the payments are spread over 20 years and discounted at 8%. This shows why understanding the time value of money is important, where money received in the future is worth less than money received today. Next, in this question, you receive $20,000 from your great aunt. You plan to spend $3,540 every year and you can earn 12% interest on the remaining balance. The main objective is to find out how many years the money will last. So we start with the present value of an annuity formula where PV equal to PMT times 1 minus in bracket 1 plus I to the power of negative n over I. So we already know the PV is $20,000, the PMT is $3,540, and I is 12%, which is 0.12. We want to find n, so first rearrange the formula to solve for n. First, PV times I over PMT equals to 1 minus in bracket 1 plus I to the power of negative n. Then, in bracket 1 plus I to the power of negative n equals to 1 minus PV times I over PMT. Next, use natural logs to solve for n, where n equals to negative ln of 1 minus PV times I over PMT divided by ln of 1 plus I. Now, substitute the formula where n equals to negative ln of 1 minus $20,000 times 0.12 divided by $3,540 divided by ln of 1.12. Then n equals to negative 1.134 divided by 0.1123 equals to 9.998. So n equals to approximately 10 years. So the inheritance will last approximately 10 years. This means if you withdraw $3,540 every year with 12% interest, the money will run out after about 10 years.
Hello, my name is Shafika Nabila binti New Zealand and my matrix number is BB23110360. So I will discuss for question 18. Suppose you know that you will need $2,500 2 years from now in order to make a down payment on a car. For part A, Bank 1 is offering 4% interest compounded annually for 2-year accounts, and Bank 2 is offering 4.5% compounded annually for 2-year accounts. If you know you need $2,500 2 years from today, how much will you need to invest in Bank 1 to reach your goal? Alternatively, how much will you need to invest in Bank 2? Which bank account do you prefer? The solution, I use formula future value equals present value, open bracket 1 plus I, close bracket to the power of n. To find present value equals future value divided by open bracket 1 plus I, close bracket to the power of n. So 2500 divided by open bracket 1.04 close bracket square. So the answer is $2,311.39 for the bank 1. For the bank 2, I use the same formula and the answer is 2500 divided by open bracket 1.045 close bracket square, and the answer is $2,289.32. I will prefer bank 2 because its interest rate is higher, 4.5%, which allows my money to grow faster. As a result, I need to deposit less today to reach the same future amount of $2,500 in 2 years. For the part B, now suppose you do not need the money for 3 years. How much will you need to deposit today in bank 1 and bank 2? For bank 1, I use formula future value equals present value, open bracket 1 plus I, close bracket to the power of n. To find present value equals future value divided by open bracket 1 plus I, close bracket to the power of n. So 2500 divided by open bracket 1.04 close bracket cube. So the answer for bank 1 is $2,222.49. I use the same formula, which is future value equals present value, open bracket 1 plus I, close bracket to the power of n. To find present value equals future value divided by open bracket 1 plus I, close bracket to the power of n. So 2500 divided by open bracket 1.04 close bracket cube. So the answer for the bank 1 is $2,222.49. For bank 2, I use the same formula and the answer is 2500 divided by open bracket 1.045 close bracket cube, and the answer is $2,190.74.
My name is Kelvin Tanjajun. My inventory number is BB230106774. There I'm going to present question 24, which is suppose you have 3 personal loans outstanding to your friend Elizabeth. A payment of $1,000 is due today. A $500 payment is due 1 year from now, and a 250 payment is due 2 days from now. You would like to consolidate the 3 loans into one with 36 equal monthly payment beginning 1 month from today. Assume the agreed interest rate is 8%. A. What is the annual percentage rate you would be paid? B. How large will the new monthly payment be? For A, the formula is APR equals to open parenthesis on 1 plus the effective annual interest rate. The annual percentage rate represents the total cost of borrowing on an annual basis expressed as a percentage. It includes the interest rate, fee, and any other charge associated with the loan. For this particular case, we are calculating the APR based on the effective annual interest rate of 8%. This gives us a clear understanding of the total cost of the loan over a year. Interest rate is, which is IEFF, is the effective annual interest rate expressed as a decimal. In our case, IEFF is 0.08 or 8%. First, we calculate the monthly interest rate by adding 1 to the effective interest rate, raising this sum to the power of 1 over 12. Since there are 12 months in a year, to account for monthly compounding and then subtracting 1. The final answer of the APR is approximately 7.72%. This represents the true cost of the loan on an annual basis. And let us move on to the B, which is how large will the new monthly payment be? After consolidating the three loans, we need to figure out the new monthly payment for the borrower. The total present value of the consolidated loan is $1,677.30 and the borrower will make 36 equal monthly payments. So the formula is above, which is PMT is the monthly payment, PV is the present value of the loan, which is $1,677.30. I is the monthly interest rate, which is we already calculated in 0.006433. N is the number of month, which is 36. When we perform this calculation, we can get a monthly payment of $52.35. This is the amount that the borrower will need to pay each month for the next 36 months. That's all from me. Thank you.